a trapezoid, rhombus, and kite. All right, so we're going to start with area of a trapezoid. In the video, remember that was the one that I took two trapezoids and I flipped one over and I put them together and they made a, do you remember?
Parallelogram.
A parallelogram, okay? So for the formula for area of a trapezoid, actually we'll just go here. You are doing 1/2 times the height times the sum of your two bases. So base 1 plus base 2. That's the formula that you're going to use if your trapezoid looks something like this. Okay, you'll have a base here, a base here. So the two that are parallel are your bases. Those are the two that you want to add together. Okay, that's your B1 and your B2. And then your height will be what is perpendicular to those two bases. So you're going to take those three things and plug them into that formula. Okay, 1/2 times the height times base 1 plus base 2. All right, so I'm not even going to give you a basic one right now because we did a basic one in the video. But just a more complex one just so you can see where this 30, 60, 90 business kind of comes into play here. Let's say I give you this. This is 5 meters. This is 7 meters. And then there is a 60-degree angle down here. Okay. So this is a trapezoid, one pair of parallel sides. You need a base 1, a base 2, and a height to find the area of that trapezoid. Do we have any of those right now? We have the two bases, okay? So if we're saying area equals 1/2, the height we don't know yet, but we do know our base, I was gonna write numbers in, base 1 and base 2 are 5 and 7. So 5 plus 7, okay, and the order you do these in doesn't matter, but I'm just gonna put it in the order of the formula. So we need this, we need H right here. You have a 60-degree angle. And like I said, whenever you see a 60, a 30, or a 45, find the triangle that will help you. So if I draw this line in right here, now I have a 30, 60, 90 triangle that I'm looking for this side of. Do you know any side of that triangle?
Yeah.
Which one? The bottom. Right, so this one down here, because this is 5 and this is 7, you're just subtracting those. 7 minus 5 means this is 2. So what's the height? In a 30, 60, 90, it's 2 rad 3, right? So it's your leg times rad 3. So you're going to plug in right here 2 rad 3. Okay, now to simplify that formula, just make sure you're paying attention to PEMDAS. We're going to put it in simplest radical form, so you're not just going to plug it straight into your calculator. It's going to be 1/2 times 2 times 12, right? 5 plus 7. So 1/2 times 2 just is 1. So really we have 12 and a rad 3 that we're multiplying. We were talking meters, so that would be square meters. Okay. Questions on that? Okay, look for the 30, 60, 90, look for the 45, 45, 90. Ryan, are you with me right now? Yeah. You better hope you are. Okay, next formulas. These ones are beautiful because they're the same formula for two different figures. So if we are talking area of a rhombus, or area of a kite, okay, the formula we're going to use with that is area equals 1/2 times diagonal 1 times diagonal 2. Just keeping in mind that D is always diagonal. Okay, so we don't want sides of the figure anymore. We want the diagonals. The diagonals cut through the figure. So let's say I give you this figure. Side note, when you're trying to draw a kite, it's way easier to draw a kite by drawing the diagonals first. So I would do, for instance, something like this, and then connect your diagonals endpoints. That one was not great. But it's easier to do it that way. Really didn't do a great job. So your sides, or parts of your diagonal, this would be 2, this one's 5, this is 3, and 3. Okay, so the 3 and 3 are those two. So if the formula is 1/2 times diagonal 1 times diagonal 2, what is the length of one of your diagonals? 6, right? You're going to add these two together. So that would be diagonal 1 or diagonal 2. It doesn't matter. Okay. The other diagonal then is putting those two together. So diagonal 2 is 7. So you're just doing 1/2 times diagonal 1 times diagonal 2 for your area. Excuse me, and you get 21. We're going to say we were talking meters here. I didn't label any of them meters, but so that would be 21 square meters. Okay, so your diagonals on a kite, those are cutting through the kite, not sides of the kite. Questions on that? All right, last one. Okay, so this one's going to be a rhombus. If you draw the diagonals of a rhombus first, it's easiest as well. Just make your two sides of your diagonals as equal as you can, so that it actually looks like a rhombus. So let's say this is a rhombus, and we are told that this length is 15 centimeters, and this length is 12 centimeters. We know the diagonals of a rhombus are perpendicular, right? So that's helpful. Diagonals of a rhombus are perpendicular. I need to know my two diagonals, because the area is 1/2 times diagonal 1 times diagonal 2. So diagonal 1, we'll just call this one. Diagonal 2, we'll call this one. We need to know those lengths. Do you know either one of them right now?
You know 24.
Right, diagonal 1 would be 24, because the parts of a rhombus are always bisecting your sides. So this diagonal 1, is 24, just adding those together. Does anyone see a way you can find diagonal 2? Yeah.
Could use the Pythagorean Theorem.
Right. So just like we did with the 30, 60, 90 and the 45, 40, 45, 45, 90, that's where we also did the Pythagorean Theorem in that chapter, right? So if you're looking just at this triangle right now, I have a side that's 12, a side that's 15, and we don't know that third side. Is that one of my legs or my hypotenuse? It's a leg, so that's got to be with your 12 squared, right? So if we call this x right now, we would say x squared plus 12 squared equals 15 squared. And then it's just a matter of solving, doing the algebra here. So if we do 15 squared minus 12 squared, what does that come out to? 81. So you get x squared equals 81 if you take away the 12 squared from both sides. And then you just need to square root that, and you get x equals 9. So if we're looking at our picture up here, that makes this x 9. What is this piece? 9 also, okay? Those diagonals always bisect each other. So that means diagonal 2 is 18 units long, right? We want that whole thing. Add these two together, 9 and 9. So if we're looking for the area, we said it's 1/2 times diagonal 1, which is 24, times diagonal 2, which is 18, and then just plug that into your calculator. 1/2 times 24 times 18 is 216, and we were talking centimeters, and it's area, so square centimeters. Okay? Any questions on those?